This one-transistor blink circuit is very popular on YouTube. It looks like it must be fake. It breaks all the rules. A single transistor hooked up backwards with its base floating in mid-air. And yet, it blinks. So how does this dirty blinker work? In this video, we will have a closer look at this amazing circuit. Let's have a look at some signals in this dirty blinker circuit to understand how it works. I connected the oscilloscope to the emitter of the transistor like in the schematic on the right. Now I increase the voltage. At about 12 volts, the circuit starts to oscillate and the LED starts to blink. If I further increase the voltage, the oscillation will be faster. Now let's have a look at this waveform. Here the capacitor charges via the 1K resistor to about 12 volts. Then the transistor conducts and discharges the cap via the LED to about 10 volts. Then it charges again. So the transistor switches on at 12 volts. Why does it switch on? And why does it switch off again? To understand how this works, we will need to go back to the basics. What is a transistor? How does it work? An NPN transistor is made of an N, P and N layer. One P to N junction acts like a diode. So it looks like two diodes connected head to head. But the cool thing of a transistor is that the middle P layer is shared, so you can inject electrons in it via the base. Normally, current cannot flow from the collector to the emitter because the upper diode blocks it. If you let some current flow from the base into the emitter, you inject charge carriers in the P material of the base. Then it's not good P material anymore, so these diodes are not diodes anymore. Now electricity can freely flow through the transistor from the collector to the emitter, and you only need very little base current for that. To get a high amplification, the emitter silicon is heavily doped, for instance with phosphorus atoms, and the collector is only lightly doped. So the upper diode is different from the lower one. The upper diode is a good diode. For a BC547 it can block up to 50 volts. The lower diode, from the emitter to the base, is not great. It is not meant to block voltages. The BC547 specification mentioned it can only handle maximum 6 volts. I tested it with my Zener tester and there is some margin. In practice it will start leaking at 8.5 or 9 volts. This leaking is called avalanche, because the effect amplifies itself. The more current, the more it leaks. Now if we connect the transistor upside down, like in the blinker circuit, we only have this 9 volts blocking diode. The other one is connected to conduct. Then if this lower diode starts to leak, you push some current into the base material from the wrong side. But the transistor doesn't care. It will just turn on. Now the avalanche effect starts. Fast electrons knock loose more electrons in the silicon, making the transistor conduct even better and better. Now, why does it turn off again? Well, the capacitor will discharge and the voltage will decrease rapidly. When we get close to the transistor breakdown of 9 volts, the current reduces. At some point you reach the balance where the avalanche effect produces not enough electrons anymore to sustain the current and the transistor stops conducting. Now the capacitor will slowly charge and the process starts all over again. This avalanche effect depends on the structure of the transistor and it is not specified. Also, your transistor will not be happy in avalanche mode. It can damage the transistor, so normally you avoid this to happen. So using this mode of operation of a transistor, is highly unpredictable. You cannot simulate or calculate very well what will happen. Now, is this circuit any good? Well, it is interesting how it works and fun to play with. But because it fully relies on the parasitic behavior of the transistor, you cannot guarantee it will work. On top of that, the avalanche mode may even damage the transistor. So is it useful? Well, it is, because I learned something myself when making this video. And as an engineer, it is always good to understand the sensitivities and limitations of the component you use. I hope you liked this video. If it was useful for you, please like and subscribe. And leave your experiences in the comments.